Hello everyone. So in this video we are going to find the summation of this guy. The summation from k equals 1 to 89 of the sine to the power of 6 k degrees. So we are going to calculate it without calculator. So it looks a bit scary because there is a power of 6 in the beginning, but let's write the summation out so to see if we can get some insight. So it's equal to sine to the power of 6 1 degree plus sine to the power of 6 2 degrees plus until sine to the power of 6 89 degree. So looking at this summation, and it reminds me a very nice fundamental trigonometric identity. Is related to the first term and the last term. And remember, we have a very famous trig identity. It's a sine square theta plus cosine square theta is equal to 1. So although the power is different, but we can still try to manipulate the expression and express it into the power of 2, the square, so that we can simplify the expression. And we also remember there is another simple trig identity, which is sine 90 degree minus theta, which is equal to cosine theta. So we can put it in the expression, and then we can express the equation with the sine ratio. So we can write it as a sine square bracket 90 degree minus theta, which is equal to 1. And so if we can express the above summation in terms of the square version, then we can simplify the expression a lot. And for example, if the theta is equal to 1 degree, and the second term, which is a sine square 89 degree, and their sum is 1, it's very nice. So what about if we try to find the general expression for the whole summation in the next part? So let's try to simplify this expression first. And we can simplify the second term first, because we can use the previous identity sine bracket 90 degrees minus x, which is equal to cosine x, and then we give it a power of 6. And then the sum of the two terms with power of 6 reminds me the cubic identity. The cubic identity is like this: a cube plus b cube is equal to bracket a plus b, and a square minus ab plus b square. So we can factorize it using the identity. So we can write it as sine square x plus cosine square x, because we are treating the 6 as a power of 2, and then the whole expression as 3, and then we do it like similar to the cosine term, and then we multiply it with sine to the power of 4x minus sine square x times cosine square x, and then plus cosine to the power of 4x, like this. And then we have a very nicely expression here, which is equal to 1 sine square x plus cosine square x, and then it is equal to 1. And then for the expression at the back, we have another sine to the power of 4 and cosine to the power of 4. So let's try to completing the square. So we can write down the sine to the power of 4x plus 2 sine square x cosine square x, and then plus cosine to the power of 4x, and we plus this term, and then we at the same time minus the same term at the back, and then don't forget the original minus sine square x cosine square x. So I can write it like here, minus sine square x cosine square x bracket. And so now we have a very nice expression, the first three term, and we can factorize it out as a sine square x plus cosine square x close bracket to the whole square, and then we minus 3 sine square x cosine square x, and we close bracket, and then very nicely this expression is also equal to 1. So we have 1 minus, and looking at this product sine square x cosine square x is not very nice because we are doing the summation. So how about we express it in terms of a single trigonometric ratio? And it reminds me of the double angle of sine. So we know that sine 2 theta is equal to 2 sine theta times cosine theta. And then we can divide the 2 to the left hand side, and then we can take square on both sides. So the right hand side is exactly this expression. So we can okay, I can write it a little bit down here. 1 minus 3 times 1 over 4 sine 2x, and then we give it a whole square here. And then we are now ready for the summation in the beginning. So let's try to write it out, the terms in the summation. So I'm going to group the terms at the same time. So we have sine to the power of 6 1 degree plus sine to the power of 6 89 degree, and then plus sine to the power of 6 2 degree plus sine to the power of 6 88 degree. And then we are grouping them like this. And then we know that there are many pairs of similar pair until we are adding in the middle. So what is the middle terms? It's a sine to the power of 6 44 degrees plus sine to the power of 6 66 degree, and then plus there is a single term for the sine to the power of 6 45 degree. So how many pair of terms in here? And it's very simple. We just count the beginning term 1 2 until 44. So there are 44 terms here. And then for the sine to the power of 6 45 degree, we can express it as the sine 45 degrees like this. And we have a very good answer for the sine 45 degree. There's a special short form, which is root 2 over 2 or 1 over root 2. And so we can write it like 1 over 8 here. And so we can express the original summation like this. And it is equal to 1 over 8 and then plus. Because we are summing the 44 terms here, so we are going to use the summation sign from k equals 1 to 44. And then because we simplify the sum of sine to the power of 6x plus sine to the power of 6 90 minus x before, so we can write it like bracket 1 minus 3 over 4 sine square 2x here. Sorry, should be equal to k. Yes, like this. And so we can further simplify these expressions. And the 1 over 8, we put it here, and then the summation can go inside the two terms. So for the first term, we are summing 44 ones. So we are plus 44 here. And then minus the constant term 3 over 4, we write it in the beginning. And then we are going to do the summation from k equals 1 to 44 sine square 2k. And then, so we are going to do the summation on this term. And then first, we add up these two terms, which is 353 over 8, and then minus 3 over 4. And this expression is just like this. It's a sine square 2 degrees, and then plus sine square 4 degrees plus until in the end sine square 88 degrees. So this pattern is very similar to our previous work, because the beginning and the end, they are the same format as the sine square x and then sine square 90 minus x. So we can simplify it again. So it's 353 over 8 minus 3 over 4. And then we can further simplify it as the summation from k equals 1 to k equals 22. And then in the middle is sine square 2k plus sine square 90 minus 2k, like this. Wow. So we write the remaining terms here. And then what are these guys? These guys is equal to 1. And then we have 22 pairs of 1, so we write 22 here. And then we are going to finish the question soon. And then 353 over 8 minus 66 over 4. And then we times 2 in both numerator and denominator. And we are 353 over 8 minus 132 minus 8. So it's equal to 221 over 8, which is the final answer for this summation. And I hope you guys like this video, and we will see you in the next video. Bye bye.